Hi guys, we're going to talk about area of triangles today. And the first thing we're going to do is a little warm up for you. And this is definitely not a triangle. This is a parallelogram that we talked about last time. And so we want to know if you have a poster in the shape of a parallelogram and the base is 12 and the height is 18, what is the area? So you're going to have to remember what our parallelogram area formula is, and hopefully you remember that it's the exact same as the area of a rectangle, which is base times height. The only thing you have to be careful of is that the height makes the right angle, which is what it's doing here. So you'll take 12 times 18, and I'm going to guess most of you are going to go to your calculator here. I am too, so I'm not judging anybody. And we're going to get 216. Now, we're not going to just write 216. We're going to write inches squared. Because remember, when we're taking the area, we're counting up how many little squares would be on the inside of that parallelogram. So why did we talk about parallelogram warm-up when we're talking about triangles today? Well, that's because while you have a rectangle, which is a special parallelogram with 4 right angles, there's a special triangle that's related. A right triangle is a 3-sided polygon with 1 right angle. So we can draw a line right here, and we have 1, 2 right triangles. So that's kind of interesting that it can take 2 triangles to make up 1 rectangle. So let's think about that. If the area of a rectangle is base times height, how will the area of this triangle be? Well, is this triangle going to have more or less area than that rectangle? The triangle is going to have less area, right? So it's not going to be base times height because it's less than that. How much less? Well, where did we cut it? We cut it right in half. If you take half of the base times height, you're going to get the shaded area. It takes 2 triangles to make 1 rectangle. So if we take base times height divided by 2, that's going to be our area of a triangle. So let's look at that a little bit further. They want to say, instead of writing base times height divided by 2, this paper is saying that it's 1/2 base times height. That's okay. These two things mean the exact same. I think my students have a little bit more success with this because a lot of you guys are hesitant to use fractions, and that's okay. That's your choice. But this is also good. You also could write 0.5 times base times height. Either way will be acceptable. So the area of a rectangle in this picture is 24 square units. So let's pretend there's 24 squares here. If you cut it right here, what is the area of the triangle? Well, if the whole thing is 24, there's 2 triangles that make that up. We should divide it by 2, and we will get 12 square units for the area of that triangle, because you would have 12 here and 12 here, and when you put it together, that would be 24. So rectangles seem pretty easy, and right triangles, but what about other triangles? It does work for all triangles because all of these triangles can fit inside a rectangle if you double its pieces. So there's a couple ways you can think of it. You can think of it here. They drew the height in, and then they doubled the piece over here, and they doubled the piece over here. So that's half of that, and that's half of that. So it's half of a triangle. You could, this is kind of out of order, isn't it? This guy kind of goes with this one, and this one kind of goes there. But I didn't do this. If you have your height right here, and you completely double this triangle, like they did here, there's half and half, which makes the whole parallelogram. The same thing could be true on this one. If you draw your height in, if you double this guy like they did here and double this guy like they did there, you'll get a full rectangle. So it works for all triangles, not just right ones. You have to make sure, though, that your height makes a right angle still. And sometimes that right angle is even going to be on the outside of the triangle when you're figuring out how tall it is. So look at this drawing of a triangle with a rectangle. The triangle and the rectangle have the same base and the same height. So if the area of the whole triangle is 48, this is the triangle, what does 1 and 2 have to be when you put them together? Well, this matches with this, and this matches with this. So if you take 48 for the blue, what does the pink have to be? Well, it also has to be 48. So this 48 for the blue, and then when you put these two together, it's also 48 square units. I could also ask you how much is in the whole rectangle, and you could just take 48 plus 48 or 48 times 2 and get 96 square units. But this question was just asking us for the pink pieces. So let's do some practice finding the area. These are all triangles, so our formula is going to be base times height divided by 2. So here's that right angle. So this will be my height. There's the base, which will be the base of 7. And this time they're both the same. And that's going to be okay. You can have the same base and height. 7 times 7 divided by 2 is going to give you a decimal, which is not a problem, 24.5 centimeters squared. What about this guy? The base is 6, the height is 5, and then we'll use that formula and divide by 2. 6 times 5 is 30. 30 divided by 2 is 15, and this time we're counting little square feet. Let's do a little more practice. Whoa, they have lots of numbers here. Is this going to confuse us? They also want us to find the base and the height. Well, for this triangle on the left, the base and the height will make right angles with each other. So when you find that right angle piece, that's a good hint of what we're looking for. The base is going to be the 9, and the height is going to be the 14. They gave us some extra slant heights that we don't need to try to throw us off. So you're going to take the 9 times the 14 to do the base times height. You're going to remember to divide by 2 because that's what the formula tells us to do. And we're going to get 63 centimeters squared. When you look at this next question, there's still some extras. There's that right angle we're looking for. So my base is 10, my height is 15, and I'm going to take 10 times 15 divided by 2. That's going to give me 150 divided by 2, which is 75 square feet. How about some word problems? So Larry is making a felt pennant. It's the same color as his favorite basketball team. How much fabric is he going to need for this pennant? Well, this time the triangle is kind of turned a little bit, but you should be able to tell that this is the right angle. The base and the height meet at the right angle. So even though the base is on the left here, that's what you need. You can just picture standing the pennant up, right? So that 30 is the height and 12 is the base. So 12 times 30 divided by 2 is going to tell us the area of that fabric and how much Larry's going to need to make his pennant. And that's going to give us 180 inches squared. He also is making a multicolored flag banner. So he cut a total of 20 triangles. Wow, he made a lot of triangles, guys. And he glued them to yarn to make this banner. How much did he use? Well, if he used 20 triangles, what's our plan going to be? Well, they gave us a nice picture here for one of the triangles. Let's use that to find the area. And then we should just be able to multiply it by 20 to get the total fabric. So this time it's kind of upside down. There's the base. The height is kind of upside down, like we said. The base times the height, divide by 2, will be 6 times 12, divide by 2, which is 72 divided by 2, which is 36 square inches for one of these. But he had 20. So we're going to take 36 times 20 to get the total amount of fabric he used, which is 720 square inches. Okay, so now we're going to talk about Sandy. Sandy has a garden in her backyard, and this is what it looks like. What is the area? Well, this would be the right angle, even though they didn't draw it in. We're looking at base times height divided by 2. So 4 times 6 divided by 2, which is 24 divided by 2, and 12. This time we're talking about square feet. That one was kind of an easy one. So the drawing shows the dimension of her garden. This time she has fertilizer that she needs to cover it. How many bags of fertilizer is she going to cover? Well, we just said that her whole garden is 24 square feet. So the fertilizer covers 3 square feet. So how many bags are we going to need? Well, if you divide 24 by 3, that will tell us how many bags she will need to cover all those little squares, because each bag only covers 3 squares and she has 24 squares that need covered. So she will need a total of 8 bags. And I think that's it. So we'll be able to start our homework and get going.